Alright, today we're going to talk about graphing functions. Alright, so let's start off. So this is how we're going to graph the function. A function has an independent and a dependent variable. Alright, you can see our independent variable here is x, our dependent variable is y. So we've chosen values of x, and you're going to see with y, when y equals x, what does y equal? Well, y equals, when x is 0, y equals 0, so our y is 0. Here, y equals 1, so y is 1. Not too difficult right here. Y is equal to 2, so we have 2. And here, y is equal to negative 2, so negative 2. Now, what I want to do here is I want to graph them. So here, my ordered pair is 0, 0. So I'm going to put that on the graph. I'll put that right there. Alright? Next, it's 1, 1. Then 2, 2. And then negative 2, negative 2. And so I end up having a line that looks about like this. Hopefully, you can draw a little bit straighter than I can right here. Alright. So we have our x, have our y. Now let's look at a little bit harder problem coming up. Now here is y equals x squared. So let's fill out our table again. Here, y is equal to 0 squared. 0 squared equals 0, so y is equal to 0. Here, y is equal to 1 squared. 1 squared is 1 times 1, so 1 squared is 1. Here, y is equal to 2 squared. 2 squared is 2 times 2, so in this case, y is equal to 4. And here we have negative 2 squared. Negative 2 times negative 2 is also 4. So you'll see here, if we graph these ordered pairs at 0, 0, 1, 1, 2, 4, and negative 2, 4, we end up, if you'd fill in everything in between, what we'll call a parabola. Alright? So that's how we would graph that function there. You can see if we filled in y equals negative 1, it'd be negative 1, 1. So that's how we fill these out. Now sometimes they want us to match the graph with the equation. The way we do that is we make a table for each equation. So an XY table for each equation. See if they match up with the graph. Now the easiest number to always check is 0, because anything times 0 is 0. So here we'll go x is equal to 0, so that would be 2 times 0 plus 1. That's 0 plus 1, which is equal to positive 1. Now you can see here that when x equals 0, y here actually equals negative 1, which means that this graph is not a possibility. Alright? So let's move to the next one. We're going to move an xy graph down here. Alright? So we're going to have x and y. We're going to check 0 again. So we have negative 2 times 0 minus 1. That's 0 minus 1, which is negative 1. So far, negative 1, negative 1. We're good. Now let's check, how about positive 1? So if we check positive 1, that'd be negative 2 times positive 1 minus 1. That's negative 2 minus 1, which equals negative 3. So here we're need negative 3 at positive 1. At positive 1, you can see that we're at negative 3. It's always good to check 3 points just to make sure. So I'm going to erase some things here, give us some more room. Alright, so let's do our last one up here. So let's check negative 1. So negative 2 times negative 1 minus 1. So we're going to try negative 1. Alright, that is positive 2 minus 1, which is equal to positive 1. So when x is negative 1, y is positive 1. Is that true in our graph? It is. Negative 1, positive 1. So I think it's probably safe to say this is our correct equation for this graph. Let's check an example here for the last one just to make sure though. So if let's say we do x is equal to 1. What is our y? Well, if x is equal to 1, that's 1/2 times 1 minus 1, which is equal to 1/2 minus 1, which is equal to negative 1/2. Well, x does not equal negative 1/2 at positive 1 equals negative 3, just like what we had with this equation. So, perfect. We did it just right. Hey, that's all I've got. Hopefully this makes sense, but if not, again, like always, feel free to ask questions. See ya.